Good morning, everyone. How's it going today? Today we're going to be taking a very quick look at Kimi K3, how it works, why it is such a big deal, and how you can use it. So, in case you were sleeping or under a rock during the weekend, or maybe you were too busy with the World Cup, Kimi released Kimi K3, and it took the world by storm. It received so much attention that Kimi had to actually stop new subscriptions because they were running out of compute. It's the first time that I see something like this with an open source model. And as you will see in just a moment, this really is a DeepSeek kind of moment because it is the first time that an open source model tops the leaderboards on coding tasks, as we're going to see in just a moment. Later in the video, I'm also going to show you some tests that I ran myself on token usage, time per task, and quality on Kimi K3, Opus, Sol, and Fable so that you can actually see how this model compares to other state-of-the-art models that we have available. So, what we're going to be doing today is, first of all, see what is Kimi and why it is such a big deal. Second, I'm going to go over a quick selection of benchmarks so that you can see how it compares to other state-of-the-art models. Then I'm going to show you my personal tests on a real coding issue to compare quality, cost, and time per task for each one of these top models. And finally, we're going to see how you can use this model on Pi, OpenCode, or Tau. So let's get right into it. All right, so let's start off with a few aspects of Kimi K3 just to give you a very clear idea of what the model is about. So first of all, the model is massive. It is a 3 trillion parameter model, well, 2.8 trillion parameter, which puts it as the first ever open source model that is in the 3 trillion parameter model class. And as they have shown right here in this nice little plot that they put out in their website, they have on the x-axis the time, and then on the y-axis the parameter count. And as you can see, Kimi is by far ahead of the other competitors in the open source sphere. And not only is, of course, the largest open source model in the world, it is also one of the largest models, period. Also, about the specifics, we know that this model has a 1 million token context window, which makes it extremely useful for long-running tasks, especially in coding. And the model is also natively multimodal, which means that it comes right out the box with support for input not only of text, but also video and images. And as we're going to see in the next part of the video, this model actually tops a few benchmarks and comes above things like Fable, for example, in front-end coding. We're going to see that in a moment. But let me just show you real quickly, again, some of the things that it was able to build. So, for example, some 3D games right here, some other animations, this other cyberpunk kind of web-swinging game, as you can see right here. And this was all built with Kimi, and the interesting part about Kimi is that it is so good at understanding vision and image inputs that it can self-validate its own coding in order to improve it, just like it recursively did with this examples that we see right here. I do encourage you to take a look at their website to see all the examples that they have put up. One of my favorite ones, personally, and that I've been trying to replicate with other models before, is this video right here, which is kind of a imitation of the 3 Blue 1 Brown YouTube videos. And as you can see, it works pretty well. Kimi does a great job at understanding what the video is about, how the frames move. It's really good. And about the open weights, this model will be published with open weights on Hugging Face by July 27th. So let's take a look at the benchmarks now. All right, so now let's take a very quick look at the benchmarks. Of course, these benchmarks ask the different models to complete different tasks, and then we measure whether or not the models were capable of solving the tasks and the quality of this task that they solved. And then we just rank them by quality and whether or not they were able to complete the maximum number of tasks or not. So in Code Arena right here, this Arena AI, in case you're not familiar with this website, it is a site that it is crowdsourced in the sense that what happens is that they ask different models to complete a given project. In this case, it is mostly front-end projects because the users are the ones who are going to select the the completion that they prefer. So what Arena AI does is that they have the same task, for example, create a to-do list application or something like that. And they ask the same model, this same task for Kimi K3 and, for example, to Fable 5. And then the users, without knowing which model completed which task, select the one that they like the most. So it is completely blind side-by-side comparison by the users. And this is the first time that an open source model tops this ranking. It is basically kind of what happens in chess. So when two models compete, then their ELO score is updated. And then by the end, you have the top model at the top of the leaderboard. And for the first time, an open source model, Kimi K3, tops this one right here. And it comes above Fable 5, which is, to me, incredible because Fable was just about to be discontinued because it was so good, it was dangerous by the US government. So amazing news that we have this open source model right here on top. And if you want to see other rankings right here from Arena AI, you also have HTML, you have React. On React, you also have Kimi K3 on top. So for React use cases, if you're building React applications, also you probably want to use Kimi. And also for other domains such as branding, reference-based design, data and analytics, consumer product, etc. In all of this, Kimi K3 achieves the top performing results right here. So to me, that is just incredible. To me, this is one of the most important benchmarks that we can talk about. Another couple of benchmarks that I want to cover right now very quickly is, first of all, the intelligence index by artificial analysis.ai. And as you can see right here, Kimi K3 sits on a third position right after Fable 5 and GPT-5.6. Now, intelligence index is a compendium of 9 different evaluations that cover a variety of different use cases, including coding, general knowledge, specialized expert knowledge. For example, in this humanities last exam, we also have Tau 3 or Tau Cube, I don't know how to pronounce it, which is a benchmark that analyzes how good a model is at completing customer service tasks, but ones that are complex and that actually require multiple tool uses and long reasoning, etc. And as you can see right here, in this one, for example, Kimi achieved the top score above GPT-5.6 and also above Grok and the Anthropic models. And before we go to the next part of the video, I wanted to cover a little bit about Terminal Bench 2.1. Now, in case you're not familiar with this benchmark, it is a benchmark that measures a little bit more of coding-related activities. And even though it is already comprised right here within the Intelligence Index benchmark right here, as you can see, it is one of the averaged benchmarks into this intelligence index. I would like to take a look at it specifically. As you can see right here, it is a benchmark that comprises 89 curated tasks across software engineering, system administration, data processing, model training, and security. And in this particular benchmark, you can see that Kimi arrives right after GPT 5.6, which is pretty good with very similar results, and above Claude Fable 5 and Opus 4.8, which in my opinion is just crazy. We have an open source model that tops Fable 5 in a coding benchmark that is very widely respected. And another thing that I want to show you about this particular test right here is the token usage metric right here. And this basically just measures how many tokens a model used in average per task in this particular benchmark. And just for comparison, if you remember, probably you were a user of Kimi K2.6, which was a great model. I used to use it a lot. But it did have a little bit of the problem that it was a little bit too verbose, which of course translated in longer time per task. And even though it was a pretty affordable model, that did raise the cost when compared to other very affordable open source models. That was for Kimi K2.6, because in average, it spent 78,000 tokens per task in this benchmark, whereas this Kimi K3 used on average 22,000 tokens per task and received, of course, the score that we see right here, which is great score, very little tokens, and just translates to amazing results. Now, what we have been covering right now are benchmarks run by artificial analysis and independent evaluators. What I'm going to show you right now is a sort of benchmark that I did locally, where I had Kimi K3, Fable 5, Opus 4.8, and GPT-5.6 Sol, and I had them complete the same task, which is a real coding task, and measured how good they were, how much they spent, how much time they spent, how many tokens they used, etc. So let's do that right now. All right, so let me show you what I did to compare this model to other models locally and to test it on a real coding task. So what I did is I came right here to GitHub and I found a recent issue so that it is not in their training material of any of the models involved in this evaluation. And I had all the models try to solve this issue independently. And this issue is a PyTest problem, as you can see right here. It's a very straightforward problem, but it does require reasoning across multiple files. However, the solution, as you can see right here, is basically a very simple change. Not very substantial, but the models do have to reason across different files and interfaces. So what I did is I cloned this repository at the point in time before this issue was solved, and I asked all of these models to solve it independently. And the results are the following. So first of all of them completed the task successfully. All of them have passed the tests in the end to make sure that the solution actually works, but not all of them did it with the same cost and with the same quality. What I did is that by the end, I had all of the same models that participated in this evaluation, and I had them judge every single model's output, and then I averaged the whole thing to try to get away from the bias of the same model favoring its own completion. So in this case, we have this nice little plot right here. On the x-axis, you have the cost per model on this particular task, and on the y-axis, you have the quality that was given to this completion by the models that I had to be judges. So in this case, as you can see, Kimi is clearly the most affordable one at about 2 cents per task, and this other three, Claude Opus 4.8, GPT Sol, and Fable 5, were a bit more expensive, with Fable 5 being the most expensive of them all. And in terms of quality, the second place goes to GPT Sol, then Fable, and then Opus 4.8, which does kind of make sense with the benchmarks. However, something interesting right here is that Kimi K3 got the best quality of them all, which in my opinion just shows that this model is pretty good. Of course, this is just a single task. I am not running this across dozens of tasks like the benchmarks that we talked about before, but this is more of a way to manually test yourself these models against your own particular use cases. So that is for cost versus quality. And then we can also consider the time per task. Now here you can see that Kimi K3 was the slowest one of them all, even though it was the most affordable, but it did spend almost twice as much time as the fastest model in this case, which was Opus 4.8. But it did finish with about the same time as GPT-5.6 Sol, which, again, this is circumstantial and anecdotal. This is not supposed to be a scientific proof of anything, but it is a way to get an idea of how these models behave with your own code bases. I do encourage you to run these tests in your own code bases. I'm going to show you in just a moment how to do that. And just for the record, the light part right here is the planning stage, and then the darker part is the implementation stage. And when it comes to token usage, we also see something relatively interesting, which is that Kimi K3 actually used less tokens for this particular problem than GPT-5.6 Sol, which in the benchmark by artificial analysis showed that this one right here was less verbose than K3. Fable 5 was the less verbose of them all. However, the the most expensive one, and Opus 4.8 was the most was pretty expensive and also pretty verbose. Again, this right here contradicts a little bit the artificial analysis benchmarks. This is, of course, again, not a scientific truth because this is just a single run on a single issue, but it's useful to give you an idea of how these models behave. So there you go. That is how I tested the whole thing. And just to be clear, you can completely run your own tests, this kind of evaluation that I did locally in your own issues. And I'm going to show you how to do that right now. What you're going to have to do is you're going to have to go right here to my GitHub and to DuoBench. And this right here is a skill that you can load to your agent, whether you're using Claude Code, Pi, OpenCode, whatever you're using, and just install this skill. And after that, you will be able to ask your model, your agent, things like benchmark the quality cost ratio of Kimi on planning and GPT-5.6 on implementing, and vice versa on issue blah 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 of Palettes Flask, for example, or benchmark Opus and Kimi on DuoBench and produce plots about the results. And you can of course do this with your own issues and with any model that you want. This benchmark right here uses Pi in the background through RPC to spawn a bunch of multiple sub-agents and to gather the results. And then it also spawns up a bunch of judges to judge the results. And here's, for example, one of the examples that I run. And yeah, all you have to do is install it like this, and you can just start asking your Codex assistant or whichever coding assistance you're using to run this. And in order to run the model for coding, as usual, I would recommend that you use it on either Pi or Tau. On Pi, you want to have Pi updated to the latest version. Just go right here. Be sure to log in to Kimi for coding. And once you are logged in, you're going to be able to go to models. And then when you search for Kimi, just select K3 from Kimi coding, and you will be able to use it directly. Now, for now and over the next few days, K3 is only available on maximum thinking, but they will be rolling out lower levels of thinking in the next few days. That is for Pi. Tau is my favorite harness because, of course, it's my baby, and it is very straightforward. All you have to do is just same thing as in Pi. Remember that Tau is essentially just a port of Pi, but in Python. So you go right here to API key, you search for Kimi, and you select Kimi code, and then from it, you're going to be able to just do /model, just like in Pi, search for Kimi, and here you have Kimi code K3. And that basically means that you can already start using it as Kimi code K3. And as you can see, it comes with 1 million tokens context window, which is actually more than GPT-5.6 Sol, because in case you didn't know it, yes, Sol has a 1 million token context window on the API. But if you're using it on the Codex subscription, it's actually got a 250,000 context window. So that's a small difference, but quite important. And same thing if you're using this on OpenCode. Same thing, you want to have the latest version of OpenCode, and you're going to do models, and then you're going to be able to select Kimi K3. Oops, I don't have OpenCode updated. Let me just... There we go. Here's the latest version of OpenCode. And here, if you go to models, same thing. You can just open K3. If you go to providers with Control A, add provider, you add Kimi for coding, you add your API key, and you should be able to go. So there you go. Thank you very much for watching. I'm going to be experimenting a little bit with this model. I have a lot of tests that I wanted to complete, and I will be showing them to you over the next few days. Also, stay tuned for the next videos on Tau, which, as you saw, it is already pretty mature, even if it's just been a month since its release. I'll be making more videos about that in the next few days as well. Thanks a lot for watching. It's as usual a great pleasure, and I will see you in the next one.